In this example, we are given a and we are asked to verify that y equal to cx to the third is a solution of this differential equation. So first let's do that, then we will go on and look for a particular solution. So we start off with the function y is equal to cx to the third. The differential equation involves the original function y and the first derivative of y. So I'll take the first derivative. The c in front is just a constant, and the derivative of x cubed is 3x squared. So we get y prime is simply equal to 3cx squared. Now let's take y and y prime and plug them into this differential equation and see if we really do get 0. So I have x multiplied by y prime. Here's y prime. So I'm multiplying x by 3cx squared. And then I am subtracting 3 multiplied by y, and y is the original function, cx to the third. Let's calculate this. I'll distribute the x here, giving me 3cx cubed, and from that I am subtracting 3cx cubed, and that does in fact equal 0. And so we have verified that the function y equal to cx to the third is a solution of this differential equation. Now that we know that all functions that look like cx to the third, where c could be any real number, is a solution, we want to find the particular value of c that we get when we have the condition that y of 3 is equal to 2. So y of 3 equal to 2 means that when we plug x in as 3, when x gets plugged in as 3, the function y is equal to 2. So I'm going to write the original equation, the solution of this differential equation, y equal to cx cubed, and I'm going to plug in 2 for y, and I'm going to plug in 3 for x. And we're going to solve for c. So we get 2 is equal to 27c, and then I will divide both sides of this equation by 27 to see that c is equal to 2 divided by 27. That means that the particular solution of this differential equation, when we have the initial condition that y of 3 is equal to 2, is not just cx to the third, but instead I'm going to replace c with 2 over 27. Alright, y equals 2 over 27 x to the third. So I went back to this general solution and I replaced c with the value that we found. Here I have graphed the solution that we found, y is equal to 2 over 27 x to the third, and note that that solution does satisfy the initial condition that when x is 3, y should be equal to 2. But if we were given a different point, if we were given a different initial condition, we could have ended up with a different c value instead of 2 over 27. Perhaps we could have got a c value of 5, and that green graph would have been our solution. Or maybe we would have gotten a c value of 1/5, and then that purple graph would have been our solution. It's not possible. It's not that we only get positive c values. We could also have gotten a negative c value as our solution, and then that black graph would have been a solution. So all of these functions together form a family of solutions, and depending on what your initial condition is, you could end up with any one of these functions from this family as your particular solution. This kind of idea here will come up later in this lecture about the fact that the solution to this differential equation is really this entire family of solutions, and whichever one of the particular functions you end up with, how we ended up with this one particular, depends on the initial condition that you're given.